Good morning, sir. My name is Meghana. I'm from Triple E. I'm studying BTech fourth semester in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Subject is complex analysis of and probability distribution. In this subject, I will explain the topic is recombinance formula for the binomial distribution. Introduction of this topic. Introduction to binomial distribution. The binomial distribution models the number of successes in a fixed number of depending Bernoulli's trails. Each trail has two possible outcomes, success or failure. Binomial formula. Note the general pattern emerging if you have only two possible outcomes called 1 by 0 or yes or no, success or failure. In n independent trails, then the probability exactly x success. So n of x, p of x, p of power x, 1 minus p of power n minus x. There is x is equal to as success of outcomes out of n trails. P is equals probability of success. 1 minus p equal probability of failure. This is the formula about binomial distribution, and the probability of success is denoted by pi, while the probability of failure is 1 minus p. Understanding the binomial formula, the probability of obtaining exactly k successes in n trails is given by the formula p equal to x equal to k binom bracket n flower bracket k p square k of 1 minus p power n minus k. Here binomial represents the number of combination of n trails taken k at a time. P of x equal to n factorial by n minus x factorial x factorial p power x q n minus q power n minus x. Here n is represented by this starts the count of number of phase event can occur, and n of n minus x, this ends the count of number of phase event can occur. K factorial, this deletes duplications, and q power n minus x, this is the probability of failure for the x trails. P power x is the probability of success of x trails. And importance of recurrence relations. Recurrence relations provide a way to compute probabilities in a recursive manner. They simplify calculations, especially for large values of n and k. This approach reduces the amount of computations needed compared to calculation each probability independently. Recurrence relations and equations that allows us to compute the nth term of sequences from preceding terms. Example 1. Example for recurrence relations. The selection sort. In the selection sort algorithm, the total number of comparisons is given by C n equal to 0 if n equal to 1, C n minus 1 plus n minus 1 for n greater than 1. This is the example for the selection sort in recurrence relations. The recurrence formula. The recurrence formula for the binomial distribution is given by P of n comma k equal P of n minus 1 comma k minus 1. C dot P plus P of n minus 1 comma k and P of 1 minus P. This formula shows the probability of k success in n trails can be derived from the probabilities in n minus 1 trails. Binomial distribution formula. P of x equal to n x P of p power x q power n minus x equal to n factorial by n minus x factorial x into x factorial p of x p power x into q power n minus x, where n equal to the number of trails or the number being sampled, x equal to number of successes desired, p equal to probability of getting a successes in one trail, q equal to 1 minus p equal to the probability of getting a failure in one trail. Base cases of the recurrence. The base cases for the recurrence relations are essential for starting the recurrence. For k equal to 0, p of n comma 0 equal to 1 minus p power n, where signifies all failures. For k equal to n, p power n comma n equal p power n, indicating all the success in trails. Deriving probability using recurrence. To find p of n comma k, where we can recursively apply the recurrence formula. This method allows us to build upon previously computed probability. It is particularly useful when calculating the probability of varying number of success. Recurrence relation. In order to generate sequence using the recurrence relations, first we used to these points to find the recurrence relationship. Find the recurrence relation formula. Substituting the given initial value into the formula to calculate the new value u of n plus 1. Substituting the new value u n plus 1 into the formula to calculate the next value. Repeat step 3 until the desired number of terms has been generated. Example calculate. Consider a scenario where n equal to 5 trails and p equals 0.6. We can calculate p of 5 comma 3 using the recurrence relation. By applying formula, we build p of 4 comma 2 and p of 4 comma 3 until we reach the base cases. Application of binomial distribution, and this is the example of calculation of binomial distribution. The binomial distribution is widely used in various fields such as medicine, finance, and quality controls. It helps in making decisions based on the likelihood of achieving a certain number of successes. Understanding the recurrence formula can enhance predictive modeling in real-world scenarios. Limitation of binomial distributions. The binomial distributions assuming fixed probabilities for such each trail, which may not always be realistic. It also requires independence between trails, which can be violated in practice. Conclusion of this topic is the recurrence formula for the binomial distribution is a powerful tool for calculation probabilities efficiently. Understanding both the formulas and its application is essential for satisfactory analysis. Mastering these concepts can be contributed significantly to data-driven decision-making process. Feel free to adjust any content format as needed, and a binomial distribution formula is C of x equal to n c x p of power x of 1 minus p power n minus x. This is the formula about binomial distribution, and this is information about recurrence formula for the binomial distribution. Thank you.